In question 9, functions f and g are defined by f of x equals to x plus 1 upon x and g of x is equals to x plus 1. In part A, we have to find an expression for g f of x. So to find an expression for g f of x, in place of x in the function g, we'll replace it with the function f. So this will become a into x plus 1 upon x plus 1. Now we can leave this expression as it is, or we can expand the bracket and write it as ax plus a upon x plus 1. In both cases, the answer will be correct. In part B, it is saying that given that g f of 2 equals to 11, find the value of a. So in this part, basically, in the expression for g f of x, which we had found in the previous part, in place of x, we'll replace it with 2 and put the whole expression equals to 11. So this will become 2a plus a upon 2 plus 1 equals to 11. Simplifying this, we'll get 2a plus a upon 2 is equals to 11 minus 1, which is equals to 10. Taking the LCM, this will become 4a plus a upon 2 is equals to 10. Cross multiplying, we will get, so this will become 5a equals to 20. So a will be 20 upon 5, which is equals to 4. In part C, it is saying given that the graph of f of x has a minimum point when x equals to 1, explain whether or not f has an inverse. Now the values of x are from greater than 0. So let's say if we draw a graph up here and the minimum point is at x equals to 1. So which means if this is the minimum point, the graph would be somewhat like this. Now this basically means that f is not of one-to-one function, so that's why it will not have inverse. So we'll write as f is not a one-to-one function, or f of x is not a one-to-one function. It will not have an inverse. It's not one-to-one, so there will be no inverse. For a function to have an inverse, it can only be a one-to-one function. So if this graph had been like in this form, where for each value of y, there was only one value of x, in that case, this function f of x will have an inverse. In part D, it is saying find and simplify an expression for g inverse of f of x. So in the first part, we'll find an expression for g inverse of x. Now as a equals to 5, so g of x will be 5x plus 1. First, finding an expression for g inverse, so that will become y equals to 5x plus 1. Exchanging the values of x and y, this will be x equals to 5y plus 1. Making y the subject, this will be equals to x minus 1 upon 5. So once we have an expression for g inverse of x, which is x minus 1 upon 5, to find g inverse of f, in place of x in the function, we'll replace it with the function f. So for g inverse of f of x, in place of x, we'll substitute the function f. So function f is x plus 1 upon x. So writing x plus 1 upon x in place of x minus 1, and this will divide by 5. Simplifying the numerator, taking the LCM, this will become x squared plus 1 minus x upon x, and this is being divided by 5. So we can write it like this. We can simplify this to write it as x squared minus x plus 1 upon x. And when you bring the multiplication sign, this will become 1 upon 5. So the final answer can be written as x squared minus x plus 1 upon 5. In part A, it is saying explain why the composite function fg cannot be formed. Now, when we are forming the composite function f g of x, basically, this means that in the function f, we'll substitute in place of x the whole function g. Now, if you look at the function f of x, it is taking x values, only all of the x values which are greater than 0. And the function g of x has all the x values, which is basically an element of real number, which means it can be positive and negative. So the range of g of x in this whole case will be basically negative and positive. Now, as we're substituting g of x in place of x up here, so this is basically in place of x in the function x. As the range of g of x does not lie, so we will write the answer as that as the range of g of x does not lie in the domain of f of x, as f of x is, for f of x, we know that x must be greater than 0, and the range of g of x does not lie in the domain of f of x. So the final answer will be, as the range of g of x does not lie in the domain of f of x, the function fg cannot, the composite function fg cannot be formed.